Hello, ndikulandire nonse tsiku la lero pamene tikupitiriza phunziro lathu la trigonometry. Lero tili mu lesson 3 ndipo mu lesson 3 tiona angle of elevation and angle of depression. Ndipo muli ndine Siselo Chuma. Tiyambe kuyang'ana angle of elevation. When we talk of angle of elevation, we consider a scenario whereby a person stands and looks up at an object. The person stands, as you can see here, and look at our person here. Stands and look at an object here. It's looking at that object up there, and the angle of elevation is the angle between the horizontal line or the horizontal line of sight. This is line of sight. Ukaima muntu. If you look straight, that line without kuyang'ana mwamba kapena kuyang'ana pansi, that line of straight line of sight imeneli horizontal. If you stand and you have that, then you try to raise your eyes up, you create an angle of elevation. Tiyelekeze muyima mumayang'ana muntengo monga nthawi ya mango muta kumayona mango muntengo. So at first umayang'ana straight, you turn your eyes upwards. If you turn them upwards, you create an angle of elevation. So this is what we call an angle of elevation. Kuchoka pa horizontal line, your eyes are kuyang'ana, then you moving kuyamba kukweza maso ako aja mpaka nokafika pa point imene ufuna kuona chinthu chako. In this case, this is where our object is. Pamene tikuyang'ana pamene. So line imene iyo imene maso ako ayenda kukafika pa object is what we call line of sight. Yeah, so we have a horizontal line of sight and we have that actual line of sight. So the angle between them is what we call angle of elevation. I hope that is clear. Let's move on. Then let's look at angle of depression. In this case, so you have horizontal line of sight, immediately horizontal line of sight. Then if you turn down, that's your object. Now it's down. So first of all, you have that horizontal line of sight. Then if you turn your eyes downwards, you find out at that angle. So that angle, that's what we call angle of depression. You need to measure that angle. Okay, we are saying that's mwamba, then okay, horizontal line of sight could be that one. Then okay, and by doing that you are creating this angle. Now for that to be measured, you have to use an instrument, and that instrument is what we call trigonometer. This is an instrument that we use to measure angle of elevation and angle of depression. A simple example of trigonometer is this protractor. A demarcated patcher. You can have you can roll a paper and it should have a through hole. Point in this case, let's use in this case your eye could be here. That's your eye. This is a protractor, and by protractor by center paja you can roll a rope, and below that rope you can put a heavier object. ka object kuti kolemererako kuti mukayinyamula protractor yanu at any angle that rope will go downwards, perpendicular downwards. So you find out that one will be measuring an angle of that elevation or an angle of depression. The actual equipment is this one. That one is what we call clinometer. You can have a clinometer by just using a protractor. So by just using a protractor, you can measure the angle of elevation, you can measure the angle of depression. Kuyangana mwamba can be measured by using this protractor. Kuyangana sopansi can be measured by using the same protractor. So that angle is measured by an instrument called clinometer. Alibosiyana siyana abanangobeka chitsanzo let. So how do you use that clinometer? See, given that an example of a protractor, okay, that is a heavy object, that's just a rope, okay. So that's from 0. So mukayimika protractor at a certain angle, see an object through that hole. If you see that object, so that angle that is being created there is what we call angle of elevation. So it's what will give you angle of elevation. In this case, if you are looking at that object here, okay, you will find out that line will give you a certain angle. Then you measure that angle. In this case, it's this 59 here. Okay, that angle is that 59. Remember, AJ is dropping down perpendicularly to the horizontal line of sight. It's dropping down perpendicular to that. So line ikubwera this side, okay, and imakhala 90 degrees. So mukapatikiza that one and that one, then you can say 180 because this one is creating a triangle. 180 minus 59 plus 90 degrees. In this case, it will give you the angle of elevation, which is that one. The same principle can be applied pamene mufuna kuona angle of depression. Instead of kuchimika ndio mutachizondotsa, okay, mutachizondotsa joncho. So you'll be looking huku, something like that. So you still do the same calculation to find the angle of depression, which is this angle. So basically, in simple terms, that's how we use a clinometer to measure angle of elevation and angle of depression. Now let us look at an example to know the angle of elevation and angle of depression imagwira ntchito bwanji in trigonometry. Okay, example yamba, here we look at this building. Tindi building yaitali kwambiri imene sitikudziwa kuti kutalika kwaje ndiyo talika bwanji. Okay, so trigonometry may help us to find that height of this building without physically measuring it. This one could be a tree, could be anything else. You don't know its height, but you can use trigonometry to measure that height using the knowledge of elevation, angle of elevation, and angle of depression. Okay, so in this example, they're saying an architect wants to calculate the height of a building. He stands 50 meters away from the building. Okay, so this is the building. They are representing it by this line. Okay, this line is representing the building. In other words, okay, let's just finish the question. He stands 50 meters away from the base of the building and looks up at the top of the building. So this is your building, this side. You stand 50 meters away from the building. Okay, you stand here. Then you look upwards. Okay, an angle of elevation, you measure with that clinometer to measure that angle of elevation. Kukaona pamwamba pamene pafika building. So you find out that the angle of elevation there is 70 degrees. Now the question is, calculate the height of the building. All right, without even physically measuring the height of that building, but using trigonometry, tindikuthekera kunena kuti tikhonza kuipeza. So in this case, following that, they have created this triangle. So from that base of the building to there where you are standing, where you are measuring the angle of elevation is 50 meters, and the angle for that elevation is 70 degrees. So we can use this knowledge, this information, to calculate the height of our building by applying trigonometry formulas. So it's like now we are having a triangle as shown, and that triangle has got the opposite, has got the hypotenuse, has got the adjacent, and has got the 70 degrees. Now, using our trigonometric ratios, remember, SOHCAHTOA can be applied here. SOHCAHTOA. Okay, so in this case, tufuna upeza height, which is opposite, but we know adjacent, which means we are dealing with opposite, and we are dealing with opposite and adjacent. Okay, here there is no adjacent, here there is adjacent, but opposite is not there. But under here we have both opposite and adjacent, opposite and adjacent. So from here we'll see that we are going to use tan. So it will be tan 70 degrees should be equal to opposite, which is Z in this case. We have given the opposite side as ZM, over adjacent. Adjacent in this case is 50 meters. Okay, it's 50 meters. Right, so let's take it up there. So it means tan 70 degrees is equal to Z, which is our opposite, over 50 meters. Okay, now we want to find Z. We just make subject of the formula. Z will be equal to 50 meters times tan 70 degrees times tan 70 degrees. Okay, so this one will be equal to, we can use our calculator. Okay, we can use our calculator on this one. Okay, so let's look at tan 70 calculator. That will be equal to that one. Tan 70 is 2.7474. If you multiply that by 50, it will give you 137, approximately. We can say it's 137 meters. Of course, it's 0.4. We can just give it an approximate of 137 meters. So now we know, using trigonometry, the approximate height of our building without actually measuring from the top to the bottom. It would be dangerous kuti muyeze nditu kutenga tape measure nkuyeze building. It would be very dangerous. A building that is 137 meters tall, it's not easy. Yeah, so this is how you use trigonometry to help you solve day-to-day problems. Let's look at an example 2. In this example, they're saying calculate angle of elevation to the top of a building 10 meter high from a point 15 meter away from the foot. So this is our second example. In this one, they're saying calculate the angle of elevation to the top of a building 10 meter high from a point 15 meter away from the foot of the building. Calculate the angle of elevation to the top of a building, and that building is 10 meters high from a point 15 meters away from the top of the building. Okay, so when you have a problem like this one, you have first of all have to imagine the building. Okay, let's have a building here, something like a building here. Okay, we can have like a building here. Okay, this is your building. All right, maybe that's your building. Now having that building, there is a point. They're saying the height of this building. Na kutoka hapa ukafika pansi, akunena kuti the 10 meters. Yeah, 10 meters. Now they're also saying calculate the angle of elevation. So it's a matter of calculating the angle of elevation, okay, from the point minimum hole. Now they're saying from a point 15 meters away from the foot of the building. So the foot of the building, this is the foot of the building. Foot, the ground there to the minute. So saying from that foot of the building, away from that foot of the building, about 15 meters. About 15 meters. So height of the building 10 meters, but iwewe muntu uli apa, you're standing there 15 meters away from that, from the foot of that building. Now the question is, iwewe uli apa ukuyangana uku to the height, to the top of that building, ukuyangana apa. Now the question is, calculate the angle of elevation, which is this one. It's a theta. Let's calculate the angle of elevation. As theta. Let that angle of elevation to be theta. Okay, so in simple terms, I'll give a bad example on this one. Komano aba batokala muntu. Batokala muntu apa. Okay, batokala muntu. Now you are here, you want to assassinate that person. Now you want to find an angle yoti mfuti yako iroze muntu amene chachukwa kongoyika mwina muli mosaba ukhonza umudani umuphonya. This distance could be kilometers. This distance could be hundreds and hundreds of kilometers. Okay, mwina munamva za precision missile launchers. They almost use the same the same technology. I mean the same analysis. More or less like the same analysis. These are the basics of those missile launchers. So tukunena kuti tufuna tichotse munthu uyo apa. We want to shoot chinthu ichi apa. Let's not put munthu. Kumano mwina pali chinyama apa bakhala chinyama. Let's say nkango. Okay? Pali nkango apa. We want to kill that lion. It's on top of that building. We want to kill it, but we can't get close to it. So at that distance, 15 meters away from the building, we need to position a gun at that lion so that we should not miss it. The moment we miss it, it is going to cause problems. Okay, so you have to put your gun at a certain position, at an angle. So we want to know what is that angle going to be. So we are, in this case, that building we assume would be vertical, perpendicular to the ground. So that one is 90 degrees. So we can apply trigonometry in this one to find that angle of elevation, to find the position at which we can position our gun, to find the position at which we can launch our missile. Okay. Muna maonerako nkhondo maiko enawo. They are able to launch missiles like from Russia to Ukraine. Precision missiles. They are able to hit the targets. The whole idea is coming from here. Okay. You need to understand the angle of elevation. then that is if you do, let's say, mechanical engineering and other engineering courses, you'll be able to calculate the projectile. Okay, ngati upita kutali chicho suti chingamangoenda straight because of resistance and the like chimakatembenuka. So you can calculate all that, but at this level, let's understand my basics about. Okay, so we have positioned our gun to kill that lion on top of that building at an angle theta. Now we need to find that angle. How do we find it? Since we know the height of the building and we know the distance that we are from the base of that building, we have created a triangle in this case, actually a right-angled triangle. So we can happily use trigonometric ratios to find our angle of elevation. Okay, so we can as well bring back our SOHCAHTOA here. Okay, in this case, atipatsa opposite, atipatsa adjacent. Opposite, adjacent, which means we are going to use tan. So it's going to be tan theta will be equal to opposite, which is 10, adjacent, which is 15. Okay, now for us to find theta, we need to find tan inverse. We take tan inverse. If we take tan inverse on both sides, tan we are ajoka. So in this case, you have tan inverse over 15. Okay, so if you go to your calculator, this is your calculator. You look for tan inverse. Where's your tan? Tan. You see, that's your tan. That's your tan here. But we need that tan inverse. So you're going to go where there is a shift. So that we not use that second function, which is of tan inverse. Then after the shift, we are going to tan. You see, tan inverse is your tan. In this case, we are going to put 10. This case it's going to be 10 divided by 15. Okay, then you click equal sign. You see, which means you need to position your gun at 33.69 degrees. If you position your gun at that angle, there is almost 100% probability that you are going to kill that lion. Right? Yeah. So basically that's that. Amene mumatsatira nkhani even zaku America, I think assassin oyamba uja anampeza ndi materials, my equipment ngati clinometer, pamene amayiza ndi angle of elevation and the like, just to make sure nona kuti he hits the target. Of course, that's a bad example, but that's how these things work. Another example, now we need to look at how we can calculate angle of depression. Yeah, so example number 3, tufuna kuti tipeze angle of depression. In this case, we are saying of a point which is 25.6 meters away from the top of a tower, which is 15 meters high. First of all, you have to know that you have a tower. Okay, you have a tower. Okay, tower is the tallest point, maybe. Okay, and that tower is 15 meters, 15.8 meters high. Okay, so you are here. Now there is a point that you are targeting, and that point is 26 meters away from this tower. Okay, 26 meters away. So you measure maybe that point here. Okay, this is 26 meters away from the base of the star. Now, if you look at it, you can create a triangle. Okay, but the line of sight from the definition, angle of depression that one. Now, muntu waimapa watenga clinometer yake is trying to look at an object which is 26, should be 26. Should be 26.6 meters. Okay, so watenga kilometer akupanga measure angle now, okay, of depression 26 meters away from here, the tower he is standing on. Okay, so now we know the height and we know the distance at which we can measure that angle. We can know that angle. Okay, so the same explanation and then I would color danger upper, and now you are on top of that building. How can you position your gun to take out that danger? Okay, this scenario to color would under security, and they know they are protecting Muntu in a certain perimeter. So anyone crossing that line is a danger. Akunza muombera, akunza kumpanga take away. Okay, or could be a game reserve, and we go with this is a protected area, and the battle color muntu abobo 24/7, positioning a gun to that area. Any lion trying to cross that point, akulu awa azomba mfuti, azomba kayoti ampange neutralize lion. And dads my dads can chan just to neutralize the animal here, so that they should not get monocular through. I'm trying to give you a practical example, but basically that's that. So if you find that angle of elevation, it will help you a lot. So without using a clinometer, but if you know the distance at which that object is away from the point you are standing, it's easy to find that angle of elevation. It's easy to find that angle of elevation. So in this case, you will see that this is a tower. It's vertical, which means that's perpendicular. In this case, you have this side and you have that side. You have a right angle triangle. So Katoa can do its job. Trigonometry can do the job. Okay, so in this case, we are going to use, we have opposite and we have adjacent. Because of properties, parallel lines, because this is a line has to be parallel to that line, okay, which means this angle of elevation and that angle, this angle of depression and that angle of elevation should be equal. They are alternate angles. Okay, so we just find that. So it's tan theta should be equal to 15 opposite, which is 15.8 over adjacent, which is 26.6 meters. Okay, you can divide that, you find the value, then you carry tan inverse. Okay, so for me, I'll just do a very quick one. I'll go do sheet, take tan inverse, and the tan inverse, I'll put 15.8 over, in this case, 26.6. 26.6. Okay. Yeah, so this angle is 30.7. So 30.7, which means that one also is 30.7. 30.7. Therefore, your angle of depression in this case will be equal to 30.7 degrees. Yeah, so that's all what I had for you today. I hope you enjoyed the lesson. Tientukumane so sabata yamawa. Munalindine Cicero Juma.